Hello class, this is the last video for activity 5.1. In the previous video we learned how to determine the horizontal asymptote for a rational function. The picture you see on your screen now was the graph of y equals 2x plus 12 over x minus 4, and we determined that this imaginary horizontal dotted line occurred at y equals 2. And we did that by setting up our table to count by 500s and seeing what happens to y when x became really large and what happened to the value of y as x became really small. It looked like in both cases y approached the value 2. There's another way to handle this problem. To find the horizontal asymptote, we're going to really concentrate on these two boxes that are colored. Right? If the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is 0, or really we'd call it y equals 0. Let me just fix that. And if the degree of the numerator equals the degree of the denominator, the horizontal asymptote is found by finding the ratio of leading coefficients. Ratio of leading coefficients means just divide the numbers that are in front of the variable with the highest power or highest exponent. Also, you should note when we're talking about the degree, well, the degree is the value of the greatest exponent. For example, if I had just x, the degree would be 1. If I had x squared, the degree would be 2. If there's an x cubed, the degree would be 3. So if you recall this problem, 2x plus 12 divided by x minus 4, we had solved that by graphing, and our answer was y equals 2. But thinking about these new rules, well, the degree of my numerator is 1, right? Because the highest exponent is 2x. And remember, there's an imaginary 1 up there. We don't write the 1. This is really 2x raised to the 1. So the degree of my numerator is 1. The degree of my denominator is 1, right? Because again, we have x minus 4. The highest exponent would be x to the 1. So since our degrees are equal, we take the ratio of leading coefficients. So in this case, the leading coefficient of my numerator is 2. The leading coefficient of my denominator is 1. So 2 over 1 is 2. So here's my write-up, right? The degree of the numerator is 2, and the degree of the denominator is 1. So we find the ratio of leading coefficients. So that would be the 2 divided by 1, which is 2. And the equation of the horizontal asymptote is y equals 2. Again, this is what we discovered when we actually graphed this function, right? We ended up with y equals 2 as the equation of our horizontal asymptote. So you now have two ways to determine that equation. So let's look at another problem in the book. The next one they asked was find the horizontal asymptote for x plus 1 over x plus 3. Right, so here's the function that we're looking at. And if you remember the rules, the degree of my numerator in this case is 1, because I have x to the 1, and the degree of my denominator is equal to 1, because we have x to the 1. And again, from our rules, if the degree of the numerator is equal to the degree of the denominator, we take the ratio of leading coefficients. So since my degrees are the same, my coefficient would be 1, because this is really 1x plus 1 and 1x plus 3. So when I divide 1 by 1, I get 1, or my answer is 1. So the equation of the horizontal asymptote would be the ratio of leading coefficients. And again, remember, ratio just means division. So we're left with y equals 1. If I were to graph this and make x really big and x really small, you would see the imaginary dotted line that we come close to would be y equals 1. So for argument's sake, let's actually graph this, right? X plus 1 over x plus 3. I press graph, and I would expect that y equals 1, there'd be an imaginary dotted line that we get very close to and never actually touched. I changed my window to a 10 by 10 window by pressing zoom and 6. And that gives me a little more detail. Right? There's an imaginary dotted line at y equals 1. And if I wanted to verify that, again, I could go second window, tell my calculator to start at 0, count by 500, press second graph, and what happens when x becomes big? You see we're at 0.996,998,999. You can see we're below 1, and my graph is rising and getting closer and closer to 1, but it's never going to actually touch 1, right? So if we were to round this number, we'd end up with 1, okay? So we can just simply say y equals 1 is the equation of the horizontal asymptote. And again, I can go the other way and make x really small. And you can see now I'm above 1, getting closer and closer to 1. Right? We can call this 1. Okay. So again, I think it's probably easier, instead of having to graph the function, we could just take the ratio of leading coefficients. The last problem that they give us in the book looks something like this: 5x plus 11. Again, my degree of my numerator is 1, the degree of my denominator is 1. So the ratio of leading coefficients would be 5 and 2. So my horizontal asymptote would occur at y equals 5 over 2, or 2.5. So again, since my degrees are the same, we take the ratio of leading coefficients, which should be 5 over 2, or 2.5, 2.5. It doesn't matter how you express this. So the equation of the horizontal asymptote would be 2.5, or 5 over 2. So all of the problems we've done so far, the degree of the numerator and the degree of the denominator were the same. What happens if the degree of the numerator is smaller than the degree of the denominator? Well, then the horizontal asymptote is y equals 0. Okay, and in this class, we're not going to have a situation where the degree of the numerator is bigger than the degree of the denominator. But if that were to happen, there would be no horizontal asymptote. So for example, if I had x cubed over x squared, the degree of the numerator would be bigger, so there'd be no horizontal asymptote. But let's take a look at one more example. If I were to give you this function 1 over x minus 5, well, the degree of the denominator is 1. The degree of the numerator would be 0, right? Because there's no variable on the top or in the numerator. So this would be a case where the degree of the numerator is smaller than the degree of the denominator. And again, if the degree of the numerator is smaller than the degree of the denominator, the horizontal asymptote would occur at y equals 0. Okay, so since the degree of the numerator is 0 and the degree of the denominator is 1, anytime we have a smaller degree on the numerator when compared to the degree on the denominator, the horizontal asymptote is always going to be y equals 0. Thank you for watching.